forgot to start that. So everything that we're doing to this point, we've already done. We're just going to put things together on lesson 4-5. We're skipping lesson 4-4. Okay, the objective is to find the zeros of a function. I wrote it over here too. Find the complex zeros of a polynomial function. That's what I should have written on here, is find the complex zeros of a function. And it should be of a polynomial function. Okay, remember that to find the complex zeros of a function, you find all the real zeros and the imaginary zeros. So I think we all wrote that down already once before. Unless you were gone that day, probably don't need to worry about writing it down. Remember that a real zero is an x-intercept. So on this graph right here, this one has 3 real zeros because it crosses the x-axis 3 times. Okay? I want you to find the real zeros of this function using your calculator. So do we all know how to put these in our calculator and find the zeros? Let's just do that really fast. I want everybody to pull out your calculator. I want to make sure we know how to do this. And you're going to go to your y equals and type in that equation. I'll make it big while we... It's x cubed plus 3x squared minus 5x minus 10. Everybody got that under your y equals is where you put that. X cubed plus 3x squared minus 5x minus 10. So I'll put it in over here in case you didn't see it. X cubed plus 3x squared minus 5x. Is that what it says? Minus 5x minus 10. Whoops. Doubled one of my minuses up. Yeah. Sometimes, oh, I forgot to hit zoom 6. Get a standard window. All right, there are my 3 zeros. I can see where it crosses the x-axis. So, in case you forgot how to find a real zero, you hit second and the trace button. And that brings up the calculate menu. It says calc above trace. You go to zeros, right? We're looking for zeros, so go to number 2. And my cursor's down here at the bottom flashing, down at the bottom of the y-axis. And I am supposed to find the zero. So which one do you want to find first? The middle one? Let's go find the middle one. Okay. It's asking me, you'll notice that the calculator right now is asking for a left bound. It says left bound with a question mark right there. So all I have to do is go to the left of the zero. Now notice it's on a slant going up to the left. And so up above it is to the left of where it crosses, isn't it? And that's my left bound. So I hit enter. It marks my left bound with an arrow at the top. Now it's asking me for a right bound. So I go to the right of where it crosses the x-axis, which is, since it's slanting down to the right, is on the right. And there is my other point to mark my x-intercept, okay? And then ask me for a guess. So I go back close to where it crosses the x-axis, and then I hit enter. And it shows me that my zero is at negative 1.38. Remember, round it to 2 decimal places. So x equals negative 1.38. That's one of them. Can you guys find the other 2? You guys know how to do that? Find the other 2 zeros. You have to go to second and trace again to bring up the calculate menu. Hit 2 to find your zero. It's asking for your left bound. So I'm going to use my left arrow key to go to the left. This time to the left is below it. I hit enter and it marks my left bound. I go to the right, or back up would be to the right, and I hit enter and it marks my right bound, saying that my zero is somewhere between those two. And then it wants me to guess. I just got to get close to it. This looks like it's almost right on it. I hit enter, and negative 3.62 if you're on to the nearest hundredth. X equals negative 3.62. And the last one is 2 exactly. Okay, is that what everybody got? Okay. Now, if I was going to do this one by, if I only wanted integer x-intercepts, then 2 would be the only one that would work, right? And I could use synthetic division to divide 2 into there and reduce it to a quadratic equation, which then I could use a quadratic formula on to find those exact values instead of approximate values. Okay, any questions there? How many of you are still having trouble with your calculator finding zeros, not knowing how? Okay. Well, let me draw a picture of it right here. If I have a curve going like this, okay, and here's my x-axis going across right here. Okay, my x-intercept is right here, right? So if I place my cursor right here, and it's flashing right there, if I draw a vertical line, am I to the left of that x-intercept or to the right? I'm to the left. I'm to the left of it, right? And up here is to the right, okay? Now over here on this side, what's that? And that's to the left. You understand now? Okay. Everybody got it? Okay, so we're going to make this big again. And we are going to go to this slide right here. I think. There we go. Okay, example of finding real zeros. Okay, we are actually, everybody put this in your calculator. I'm not going to do this one. Everybody put in your calculator. Tell me how many real zeros it has when you graph it. Actually, I probably should for those who aren't here. Huh? 12x cubed minus 19x squared minus x plus 6. This one has 3 zeros. We just did that. Do we need to do it again? I was thinking this is a different problem. So, okay. You guys know how to find zeros. I'm not going to worry about that right now. Finding real zeros, you use your calculator. Everybody write that down on your 3x5 card. If you find real zeros, use the calculator to find the x-intercepts. What do I mean by an nth degree polynomial function has n zeros? Yeah, so if it was to the 4th degree, it would have 4 complex zeros. If it was to the 5th degree, it would have 5 complex zeros. So whatever the highest degree term is, that's how many complex zeros it has. What do we mean by complex zeros, you guys? Real plus imaginary zeros. And this one's going to have exactly, if you have x to the 5th, it's going to have exactly 5 complex zeros. You add all the real zeros to all the imaginary zeros, and you're going to have them all. Okay, now it says some may be real and some may be imaginary. Okay, the function f of x equals 4x to the 4th plus 7x squared minus 2 has 4 zeros because it is of degree 4. Do we understand that? Okay, find all 4. Now, I kind of gave you a hint already. If you used your calculator, you would find out that this cross at negative 1/2 and positive 1/2, or negative 0.5 and positive 1.5. Does anybody want to verify that, or do you believe me? We all know how to do it. Okay, this is your homework assignment today, you guys. I'm going to give you 5 problems like this one. This is what you're going to do. You're going to have to find all 4 zeros to this one. Some of them are going to have 3 zeros. They're going to be 3rd degree polynomials. Some are going to be 5th degree polynomials. Okay, by the way, if it's a 5th degree polynomial, There will be 3 zeros at least, because I'll make sure there's 3 zeros and 2 imaginary, so that you can reduce it to a quadratic equation and solve it. So what we're going to basically do is we're going to take our function, plug it into our calculator, find the real zeros. Okay, got it? Then after you find the real zeros, you are going to divide these into the original polynomial using synthetic division. That's why I went over synthetic division with you the other day, to reduce it down to a quadratic function. Then you're going to use the quadratic formula to solve the quadratic equation to get the imaginary zeros, and that makes all of our complex zeros, real plus imaginary. You got that? So this is what we're going to do right here. Whoops, go back to this one. I just meant to go. Okay, so here we go. We're going to start right here, and since we already found the real zeros, we're going to divide negative 0.5 and positive 0.5 into this. Which one do you want to do first? Okay, let's do, and I'm going to write it as 1/2. You can use it as decimals. What were my coefficients? What are my coefficients, guys?
4, 2, 4, 0, 7, 0.
Does everybody agree with that?
Yeah.
Okay, bring down what number? 4. And we're ready to start our synthetic division. Okay, so 1/2 times 4. Just what's 1/2 of 4? 2. Add, what do I get? 2. What's 1/2 of 2? 1. Add, what do I get? 8. 1/2 of 8 is 4. Add, I get. And 1/2 of 4 is 2. I add, I get. Now, I don't get 0 right here. Then I screwed up, right? Because if I put this in my calculator, and I know for sure that this thing right here is a real 0, that means that my remainder should be 0. Got it? If I don't get 0 there, I've probably screwed up in my synthetic division, or maybe that number right there is not a real 0. I didn't put it in my calculator right. Lydia? Well, I put this one in first, and since it's not written as a factor, you can put it in directly as 0.5. If it was written as x minus 5 equals 0, or x minus 5 is the factor with parentheses around it, then I would add 5 to both sides, and I'd get x equals 0.5. Got it? Okay, so I've reduced that. Now, I've got to do this again. I better move this over here. I got to do this division again, don't I? So I'm going to use a different color this time. We've got this one, and my number is negative 1/2 this time, right? Bring down the 4, and I'm ready to begin. Negative 1/2 of 4 is negative 2. Add, what do you get? 0. Negative 1/2 of 0 is 0. Add, you get. And negative 1/2 of 8 is negative 4. Add, you get 0. So I got 0 at the end once again, so I've done it right. Because I know that those two are already real zeros, right? So I know I've done it right. So I have what kind of function? What are these the coefficients for? For a quadratic, aren't they? How do I know? What did I start off with? What was my function to start off with, you guys? 4th degree polynomial, right? When I divided 1/2 into it, it reduced it to a 3rd degree polynomial down here. And when I divided negative 1/2 into it, it reduced it to a 2nd degree polynomial, which is called a quadratic. So what is my function? Let's write it over here. 4x squared plus 8 equals 0. All I have to do is solve that equation. I can use the quadratic formula. You're going to have to use the quadratic formula for some of them. But you know what, guys? When there's no middle term, you're missing the linear term, right? You got the quadratic term and the constant term, but you're missing the linear term. It's actually a lot easier, because all you have to do is minus the 8, divide by 4, and take the square root of it, okay? So let's do that. Minus 8, you get 4x squared equals negative 8. Divide by 4, and you get to move this back over here. And you get what? X squared equals negative 2. Can you guys see we're going to get two imaginary solutions? Because what do I have to do next? I got to square root this to get x by itself. And whenever you take the square root of both sides, you got to do plus or minus. Remember that? Okay. The square root of negative 2. What happens when you have the square root of a negative number? What is it? There's an imaginary, you have the square root of negative 1 times the square root of 2, right? And what's the square root of negative 1, everybody? I. So my answers are plus or minus I square root of 2. So now I have all 5 solutions. I have x equals negative 5, x equals negative I square root of 2, and x equals positive I square root of 2. And there are my 4 solutions, my 4 complex zeros. 2 imaginary, 2 real. Can you guys do that? All right. That is your what we're going to do for homework assignment. And here is your homework assignment. You need okay, I got to go back for a second. What? Okay, here is the homework assignment. Lesson 4-5. Instead of getting out of the book, I picked 4 problems out that we can do. Finding the complex zeros. You have 2 third-degree polynomials and 3 fourth-degree polynomials. And so you have to find all the complex zeros. That includes the real and imaginary. How do you find real zeros, everybody? Calculator. How do you find complex zeros, everybody? Quadratic equation. Okay, I'm going to pause this. So if someone's at home doing this, you might want to pause it so you can write down the homework assignment.